This meeting is being recorded.
Thank you. Appreciate it. Okay, yeah. So hopefully you guys all did Lab 1 and Vitamin 1 last week. Finished that up, turned it in. If not, hopefully you submitted an extension and are going to finish it in an extended period of time. If you enrolled in the class late and have not done Lab 1 or Vitamin 1, just make sure in your extension request to mention that, again, you enrolled very recently. Enrollment is going to stay open until the end of tonight. I'm sure all of you are enrolled, but in case you aren't yet, make sure you fill out Lab 0. We'll get you your enrollment code tomorrow, and then that's the add class deadline, so no more adding afterwards. Vitamin 2 is just released, and Lab 2 was released on Sunday. Both are due this Saturday. You're starting to see the pattern of assignments here. And after this lecture recording will be posted on the website. Does anybody have any questions about course logistics? What's going on so far? Hopefully you're all on the Ed and Grade Scope. We're all set. Cool. All right. More about course resources. You guys already know. Come here. Contact us on Ed. Or you can also email us. And again, like last lecture, you can follow along with this lecture by SSHing into Tsunami, which is OCF's like public login server, using like this format, opening a terminal locally. You don't have to do this. It just kind of helps to follow along with some of the things we're doing. So, topics for today. We're going to introduce Bash as a language and go into a bit about what it is, what it does, etc. Aspects of it. So, you might be thinking, I already know. The maintenance could run out. Just put it. Oh, prayer. Thank you, Andy. You might be wondering, I already know lots of cool programming languages like Python and Java. Why do I need to learn Bash? The reason you might want to learn Bash is because you are a systems administrator. That's not true. But you might be a systems administrator one day or need to do SysAdmin related tasks. And knowing how Bash works is pretty helpful. Say you have to run some commands all the time. You need to move this file back and forth. You need to copy certain files. You need to run certain, yeah. But you don't want to go into your terminal, open it up, manually run that command every week, every month, every day, whatever it may be. Again, you remember John De Niro said, don't repeat yourself. So what you can do instead is describe your task as a step-by-step set of instructions so that a computer can do it for you. It's almost like programming. So yeah, here's a little XKCD comic on what it is to automate a particular task. A lot of the time you think it's going to be, oh, you'll work on the original task, design the automation, will take over. In reality, you're just constantly developing the thing that automatically does the task for you and spend more time doing it than you would have on the original task. That's the joke. So yeah, does anybody have any questions about what Bash is or why you might want to learn it before we get into actually learning Bash scripting? And again, to summarize, it's just the language that you've been programming in this entire time in your terminal when you type out commands. And we're just going to actually program with it now. No questions? Okay, cool. It kind of works like you know the Python interpreter? Whenever you open a terminal, it's kind of like, in a way, you're like interpreting Bash commands, and similarly you type things in the Python interpreter. Okay, so Bash is a shell, expanded version of SH, which is also a shell, an older shell that kind of forked from Bash forked from SH's original thing. And it is also a programming language. We've covered this. In order to run a Bash script on your computer, or in your VM in this case, or on Tsunami, you either run Bash and then the path to the script, whatever directory it may be in, whether it's a current directory somewhere else, In this case, it would usually be a .sh file, or you make the file to an executable by changing the permissions such that your user can execute it. This would require a shebang at the beginning of the script to specify that I am programming in Bash, which we'll get into that a little more later. And then after you've made it an executable, you can run much shorter command /path to script. Either of these methods should work. There's like little semantic differences, but it doesn't really matter at this point. Okay, but you're probably wondering, what did she mean by shebang? It's a little special comment you put at the top of your Bash script, your .sh file. It's essentially you put your normal file name and then end it in .sh. That makes it a Bash script now. But you also need to put this at the top file. So when you run it, it'll recognize that, oh, your computer will recognize, oh, I need to run the Bash interpreter in order to interpret the commands you're giving me. You can also put like a Python shebang, for example, if you're running a Python script, so on and so forth. Does anybody have any questions so far? Okay, anybody in Zoom? Yeah. I don't think so.
It only checks that when you're trying to like execute it as like an executable, and you have like shell code in there. It should theoretically know which shell to interpret.
Yeah, if you run, that's one of the little differences between these two commands. If you ran like Python and then path to script, it would know that it's a Python script, or Bash that. But if you just ran / and then your script name, it would not know what to interpret it over, right?
Why is there a ./? It should just be /path. There's no dot.
Oh.
But yeah, no, this is right. Yeah. Just ignore the dot.
Okay.
It doesn't exist.
That was an accident. Isn't that?
No, it's dot is basically you're in the current directory, and then / means something in the current directory.
Yeah, right. Sorry, that was a typo when I made this. Okay. Comments in Bash work with a £. Pretty self-explanatory. Without an exclamation mark to write comments. Okay. Next up, we'll get into how variables work in Bash. So something to keep in mind is that white space matters. When you're declaring variables, be sure not to put space around like the equal sign. It will actually interpret that as like you're assigning the variable to an empty string. It's a pretty old programming language, so it kind of gets caught up on little syntactic things like that. So once you've assigned your variable, say in this example, you assign name to the value, and then to call it later, you would use $, and then the name of your variable to get that value. In this case, you would display the text value. Something super important to keep in mind is that unlike other programming languages, Bash is untyped. It is not dynamically or statically typed. Operations are entirely contextual. Essentially, Bash takes in everything as a character string, and then it'll determine, for example, for arithmetic, it'll go, oh, there are only numbers in this string, therefore you can add these or perform this particular operation on it. So it can get a little confusing sometimes without because it is an untyped language. So just keep that in mind. Some other little things you can use in your script is the export command. There's probably pronunciation, I don't know it, to evaluate expressions. It is part of the GNU core utils you learned about last week. The big fat guy, he created those, and this is one of them, Richard Stallman. It'll evaluate basic expressions. You can also use, this one's pretty important, the read command to take in user input. -P is to get the prompt, so you would say, in this case, it would prompt the user with the text send. And then the user would type in whatever they need to do. And then it would, echo what they had inputted, save it as a value, output that. You get the idea. Make sure to include -p, or it won't include any sort of prompt, and the user will probably just be kind of confused because you haven't told them to input anything. This $ command, $ parentheses, evaluates whatever command is inside those parentheses, substitutes the output into the script. This can be useful if you want to evaluate something, save it, echo that value. Yeah. And then finally, conditionals. So conditional checks. Actually, Albert, can you take this part?
Oh, okay. Yeah, so a conditional check essentially evaluates an expression and is synonymous with these two, like an opening and closing square bracket. And it essentially sets the exit status to 0, which is true, and 1, which is false. So you have to use a certain flags, such as like equals, not equals to, greater than equal to, less than, or less than or equal to, in order to with like variables on each side, in order to compare the variables with each other. And for example, we test 0 equals to 0, and you want to echo like a question mark, which means the exit code, and it would put out 0. If you were to say test 0 equals to 1 and print out the exit code, that would be 1. And the reason why 0 is true and 1 is false is because the exit code should, for a program that runs correctly, is always 0, as opposed to like, if the exit status is not 0, that means that something went wrong. And usually when you're like doing these tests, if you want to make like an assertion that something is true, you want to make an assertion, then you would check it via the flag, which is done here. And yeah. And yeah, so let's look at this. So we have Boolean operations as well, such as the double and the double or. Anyone here did 61B? These should be pretty familiar to you if you've seen those. If you did 61A and not 61B, and you've never done like C++, C, or Java before, these are just like the ands and ors. The reason why we have 2 of them is because if you have 1, in some languages, it interprets it as like a binary and. So, yeah. Here we have a more complex binary expression. We have 0 less than 1 and 0 greater than 1. These cannot both be true, so it would output false, which is 1. 0 is less than 1, or 0 is greater than 1. This would print out true, because we see that this is true, and we don't need a... It's essentially the same logic as like and or normally in like any other language for this one. Just remember the 0 and the 1 are flipped. Okay, and now that we have our tests, we can then use that to create if. In this case, we have if the variable that you put in here is equal to 79, then you echo nice. Are there any other examples? Okay, and then as we've already done, this is kind of just like other languages. I'm pretty sure everyone here is like doing CS or something CS adjacent, right? So, right?
Yes.
Okay. So yeah, this should be pretty familiar. This type of logic, just have a then and then close with an fi. The reason why you need to specify the close is because unlike Python, it doesn't like track your indents, and unlike Java, it doesn't track like brackets. So this is essentially how it tracks. Where are you at 86 degrees Celsius? And then there's else if too. This is reverting to Python. We have elif, and here we have if this was not true, then we print out nice. If this is true, we print out nice. If this is not true, we go through the rest of this. Here we check if it's 42, and then we print out the answer. Otherwise, we break out of this one, and then we print what our numbers, and then that's the end of our logic. Are there any questions on like conditions so far?
Can you explain one more time what $1 means there?
This is just like some expression, I think. I'll need to check. I believe like
It's like
I think it's the input. Like you write your code. You run the command, and you have like parameters at the end. And I think this is one of the parameters. I'll have to go and write the code out myself in order to verify that though. And then, oh my god. Here we see that we're getting an answer that we are reading. So this is, in these cases, it was like a parameter and that you put at the end of your command. In this case, you're reading in an answer. It's just different logic here. But here, it reads, are you 21? And then you get a bunch of choices here. So yes, we had to be family friendly, so we're giving cookies. No, that's illegal somehow. Are you? Let's not. And otherwise, which was just a star. Usually, for posterity, star usually means like anything, like a wild card. It will just force them to answer again, or we'll tell them to please answer because I don't know. This is essentially so that you don't have to use like complicated if-else statements because those can get very ugly very fast. So you'd have to do like answer equals to some string, answer equals to some other string, and that gets really annoying, right? Oh yeah.
When do you write semicolons and when don't you write semicolons?
Semicolons are for the end of this. It's basically like it's just part of the if-else syntax, I believe. Yeah. All right. Okay. I think I'm supposed to do this.
Yeah.
Okay. Let's do loops too. Are there any other questions about conditionals? Oh, those are just numbers. The arguments would be like the dollar signs, and then like $1 would be like an argument, for example. I believe for those, it's interpreting them as a string, but I'll need to double check. I think it's a string. Okay, loops. Now we have 4 loops for all your stuff and stuffs. So essentially, we have a list here of like a bunch of strings, and this is how we essentially make a list. And then for each of the strings in this, we do some echo statement, which is essentially echo like this number of sheep, and then done. So essentially, just like how if had like a then and then an fi, this has do and then done. And we can do it. You could use like a variable as like a list, or you could use a range, kind of like when you iterate in like Java, you do like for I equals to 1, I less than 10, I plus plus. Or in Python, you just do for I in range. This kind of does something similar, and this iterates through everything from 1 through 10. And yeah. And then while loops. This is while something is true is essentially while essentially checks if the condition that is given is still true after running through everything in here. And if it's still true, it'll run the thing in here. So right now we have while true. Oh, that did not look good. While true, which essentially means that it will never become false. You're just printing out like you are just executing this until true becomes false, which never happens. So it will just continue executing this until the end of time, or until you do an interrupt. Okay, now it's time to exercise.
My laptop, I can open up one. Real quick.
Okay. Is it gonna just?
Yeah, here. I can do that. We're writing a script that copies.
That copies files in our current directory into new files with new appended data contents.
Did you hear this on your laptop?
I think it's just on the next slide.
Oh, okay. My bad then. Okay.
I think this one was. I didn't make this one.
Oh, okay. I thought you were gonna do a demo. Sorry.
Whoop. Okay, so for this one, essentially what you would want to do is essentially do like a for loop over essentially a list of ls is going to return a list of strings here of all the file names. You would just want to move them around, and you just want to make like a copy of these and rename them in this way. I'm not sure if this is the best way to do. I have no idea why it says MV. This should be MV is move.
Yeah, it is.
Wait, but why did it say? Then why is the example?
That's how you rename files.
No, because it says copies on the previous slide, and then the script says renames. So let me just. No, because this is precisely the code. So I'm do you not have the are you alt or super? You're neither of them. How do you open a terminal?
Oh, super Q. I have it kind of like.
Why is
I like it. That's the button I like.
but why is Q is usually? Oh my god. Anyways.
I like Q for my terminal.
Oh. Let me just make a new directory. And then let's just make touch a couple of files, or make a couple of files. So now if we list it out, we're going to have A, B, and C here. Then let's just say let's just pretend this slide doesn't exist. Then actually wait, no, you already saw it. Let's just make a thing called like rename or copy.sh. We first have to specify like the shebang, I think, if we want to run this as like a bash file without like just running bash plus the file. So here essentially what we're going to do is make a list of files, which is going to be essentially a variable that is just the output of ls. And we don't want to copy our own shell code, so we're going to specify it's only .txt files. For file in files, we want to do something and then done. And this something is essentially just copying each of the files to its own name plus the word new before it. So we would do cp p file new file. Now we can make this one executable and run it. Afterwards, we can list all of our things again, and we see we now have new A, B, C. Okay, so this was an exercise. Hopefully you all followed along on your own laptops, I guess. Because next we're going to talk about functions. So here we can essentially just create a function that runs something, like runs some bash in itself. Here, the parameters themselves, I believe that this shouldn't have anything, but if you put in like a parameter, it's again just taking in like a $1, right? So here, you could do greet and then SysAdmin DeCal, and it's going to say, hey there, SysAdmin DeCal. And okay, so script arguments are stored the same way as functions. So if you were to do this is a bit tough to parse, but okay, so let's just say that we have a current unsorted list over here. Then we wanted to do like script.sh to make a sorted version of the list. Then obviously this would just be our list piped into the command sort, which sorts any list that's given. Then in the terminal, if we were to run this, it would essentially treat this as if it was a function and run this and get the output that is sorted. And the parameter that is given in script.sh is going to be the current directory. Does this make sense? Okay. And then, is that it for functions? Are there any questions on how functions work? The last example. Okay, so for this one, we're essentially just creating about like a script called script.sh, which takes our unsorted list and outputs a sorted version. So by doing this, we see the original listing is unsorted. We do ls piped into sort. This essentially says we take this output over here and we sort it. And then in the terminal, if we were to run script.sh, it would essentially treat this as if it was a function and run everything inside as if you had like a sort function and then ran it in like sort dot in its own like standalone shell script. Okay, so any other questions about functions before we move on? Okay, so our last topic for today is going to be streams. And this is essentially just like using the output of one thing or one function as the input into something else, which is some file. So essentially, if you wanted to like store the result of your output into something, you could just take whatever your output is, use this greater than this right angle bracket, and then into out.txt. This essentially says I'll take whatever was printed here and put it into here. So now if you were to open up out.txt, it would say hello in it. Now let's say that we already have some text in out.txt. This would essentially like create a new file called out.txt and erase pretty much everything else that was already on that file. So this essentially just makes this the contents of this. But what if we wanted to like add to the contents of it? Like we wanted to keep the contents of the original file, but we wanted to just like add some command output at the very end. What would we do in that case? We would use two angle brackets. So here, if we had text in out.txt, we would essentially just be appending our output to that file. And if the file is empty or if it doesn't exist, it works pretty much the same as using a single angle bracket. So yeah. yeah, so let's say we have like right now a.txt is empty. So let's output something. Here now, if we were to look at a.txt, you see we would have hi OCF DeCal. Now let's say we did that again. We print out hi OCF DeCal and put it into a.txt. We cat it again, and we have the same thing because we just overwrote hi OCF DeCal with itself. But if we wanted to put that in twice, we would have to add a second angle bracket, and there we go. Okay, so next we have redirection. So we use this to take input from a file. So let's say we have a file with a bunch of text, and we want to use that text as the input for a certain program. For example, sort, which essentially just sorts all the words in file. So in this case, it would essentially use a left angle bracket to take the thing in. And finally, what if you wanted to use, let's say, the output of the first command as the input to the second command? In that case, we would use a pipe, which essentially says, let's take whatever was output here and put it into the input for this next one. And then when we run this command, we take the input that was given and then just run it as at the end. Okay, so this is the end of our. I think this is the end of our talk about all the shell commands. So if you have any questions about those, now is a good time to ask. Okay, if there are no questions, there are some additional notes. For Python, you can use these commands for the tasks that are said. So argparse is for easy command line interface, fabric for easy deployment, salt for generally useful, which is generally useful for infrastructure tasks, and then psutil, which is to monitor system info. These are mostly for if you wanted to make more advanced bash apps, or not bash apps, like command line apps, using Python would help significantly over trying to make all those things in bash. However, if you can just run a bunch of command line tools and that creates your entire functionality, then you should use bash because it would save you a lot of time compared to just writing out 20 commands when you can just make a bash file and run those 20 commands with one. So this would be common file manipulation options, basic logic that we had already talked about, some basic Boolean logic, basic sorting, things like that. You can use bash for, and use Python when you need heavy lifting with complex control structures, messy states, recursion, object-oriented programming, or any of these tools. If you find yourself needing these tools, you should probably not be using a bash script for it. Also, I see a lot of backs. So there are other shells that are in use besides bash, such as, let's say, Z shell, fish, and corn shell. A lot of these shells are ZSH is what's on macOS now, I believe, right? Yeah, so there are alternative derivatives of the base SH, which is just the general Unix shell, but may have some differences in syntax. The first example I can think of is in fish, where the subshell command, which is this, does not look the same, and you're going to have to look at the documentation for each shell that you use if you say you want to stop using bash and start using fish or start using ZSH, or you have a Mac so you use ZSH. Then if something doesn't work that you expect would work in like Bash, you should read like your own shell's documentation and make sure that those things still work. And usually if they don't work, there's some alternate implementation that you can use to get it to work. But for our purposes, for our labs, etc., we will generally be assuming Bash. Although if you want to like use ZSH, that is like at your own risk. Things may or may not work the same way they do in Bash. Anyways, and then if you look at the slides, there are a bunch of links to resources as well as the man page for Bash. So if you have any questions, you should try to look at the documentation before asking, because that's generally how you would do things in like your own environment. There also Google is your best friend. If you're looking things up, there's probably other people already who have asked the same question and gotten a very detailed answer on how to fix that problem, how to do that thing. So don't try to find see if you have like a question on something, whether or not it's like a frequently asked question, and if it is, you can use Google. If you cannot find anything online, we will try to help them. All right. Cool.
Okay. I don't think there are any questions on Zoom. Does anybody have any last minute questions?
Wait, are we supposed to see this?
No, that was a long time ago. I
Okay.
They were able to see them. If not, I think I will end the call. You guys have a good night. Good luck on the lab and vitamin.